Example 6.11. Based on the same normal distribution for IQ, it's non-standard normal distribution, but it's a normal distribution. It was a normal distribution. To remember how much was the mean for IQ? 100, thank you. Standard deviation was 16. What do we need? We need the first quartile. Just a second. We had 3 quartiles in chapter 3 when we made the box plot. Do you remember the quartiles? The 3 quartiles? The first one. The second one was the same as the median. And the third one, we had 3 quartiles. So now, where do you expect the first quartile? The first quartile is less than 100 or bigger than 100? On the left-hand side or the right-hand side, based on the normal distribution? How do you think? The first quartile.
Left.
To the left, yes, here. Why? Because the definition was, how much was the probability there? Less than the first quartile. 0.25. %. We are going to take the third quartile later. It will be to the right, Q3. So now I can say, here is a 25%. 25%. Just a second, let me ask you another one. Who is the median now? We can expect the first quartile to the left, the third quartile to the right. Then now, who is the second quartile, the median? 100? Why? Actually the 100 was the mean. Why 100 is the median as well?
Because it's big of the curve.
Say more.
And it's in the middle.
Okay. I'm waiting something.
Normal distribution.
Yes, it was the normal distribution. Was what?
The center.
Yes, mean was in the center. I'm waiting. The normal distribution is symmetrical. Yeah, you are right. Yeah. Probably you thought, center is the middle is something. Normal distribution is exactly symmetrical. So the mean and the medians are same. Yeah, they are same. Yeah, 100. That is the second quartile, the median. So this one, the red one, is another 25%. And this one, 25. And this one is a 25%. So, see, look at this. 25%. A probability is given. Now, what do I need? To remember the map, I gave you the map. To the right, there was the probability. Then now, we need the z-score. From where? Z-table. Okay? So we have to take the z-score. Just a second. Do you expect the z-score will be negative or positive? The z-score was based on the standard normal distribution, right? How much was the mean on the standard normal distribution? How much was the middle value? 0. So we are going to take the z-score, and the z was based on the standard normal distribution in the middle, 0. But we need the z-score for the Q1. So do you expect a negative z-score or positive z-score? Absolutely, it will be negative z-score. Does it make sense? Because why do I ask you the negative z-score or positive z-score? Because we had 2 pages. One for negative z-score, one for positive z-score. So you have to choose the either page. I'm going to take the negative z-score, then we have to go to the page with the negative z-score. I'm going to take the positive z-score, then we have to go to the positive page. So now we need the negative one. So let me go to the negative page. Yes, here. Negative one. Now we had a probability. Where was the probability? In the middle. How much? 0.25. Where is the 0.25? Between these two. There's a 2 probabilities, 0.2483 and 0.2514. Between these 2 probabilities, here in the middle, there is the probability exactly 0.25. What do we need? Negative z-score. So let me see. Negative 0.6, 7, and 8. What we did? Take the average. So we take 2 z-scores, negative 0.67, negative 0.68. Take the average because the 0.25 was in the middle. So the average will be 0.0675. That is the negative z-score. For whom? The first quartile. So let me go back. We took the z-score. So we can expect, we can take the negative z-score, which was a negative 0.675. But it is not the answer because we need the first quartile is here. Where? It's not based on the standard normal distribution, but the first quartile must be based on the normal distribution, mean 100, and standard deviation equals 16. So we have to go back. We have to go back to here. We need another formula. You know, when we go to this way, we take off the mean divided by sigma to get the z-score, right? But now we need another one, the reverse one, to take the x-score. It will be, take the mean, add the z-score we found, time the sigma. So I can plug 100, add, we found negative z-score, negative 0.675. And how much was the sigma? 16. Please do this. 100 addition, negative z-score, negative 0.675 times the standard deviation, 16. How much?
89.2.
89.2. Absolutely, it must be less than 100 because it will be the first quartile. To the left. That's good? Okay? Okay, let me take the third quartile first. It's the same way. A probability is given for the third quartile. How much? You know, actually the third quartile must be here. How much?
0.75.
0.75. Here's a 25, 25, 25. So the probability for the third quartile must be 0.75. You can go to the positive page and look for the probability 0.75. How much would be the z-score do you expect? I mean the z-score. The z-score here. Positive 0.675. Here must be positive 0.675. How do you think? Why they are saying?
It's symmetrical.
Thank you. Nah, yes, the normal distribution is asymmetrical. So we don't have to look for 0.75. It must be the other one, the positive one, because the normal distribution is asymmetrical. So now we plugged positive 0.675 there. So the third quartile, I can say the third quartile will be the mean, add positive 0.675 times 16. So how much will be the third quartile?
110.8.
110.8. Probably must be bigger than 100. Okay? So because of the sign of the z-score, we can have the smaller value than the mean. Positive z-score, we are going to take bigger value than the mean. Does it make sense, right? Because always in the middle, there is the mean. There is a zero on the standard normal distribution. The second question, part B, it asks us who is the median. Already you answered 100. Symmetrical normal distribution, the mean and the median are same. Okay? And the very last one, '90th percentiles. You know, okay, let me make the normal distribution for IQ. Mean was 100. Standard deviation was a 16 for IQ. Here was 25% for Q1. And there is the Q3. And this one was 75%. We can say the Q1 is 25 percentile. Q3, 75 percentiles. Then now, where do you expect the 90 percentiles? Is it bigger than Q3 or smaller than Q1? It must be bigger than Q3. Because, you know, the curve is getting down, right? It's here. So it's up to the 90th percentile. I mean here. There is a probability 0.9. So here is the notation, the P90. The P90 is a notation for the 90 percentiles. So the other way, the Q1 is the P25 and Q3 will be the P75. It's good? So always we need the left probability, and it was given by the definition of the percentiles is a 0.90. So it's the same thing. So now we have a probability, 0.9. What do we need? A z-score. And then what? It's plug into the z here to get the score, 90 percentiles. Okay. Do you expect the z-score will be positive or negative for 90 percentile?
Positive.
Here. Positive. Because we can expect in the middle, it's based on the z, there is a 0, which was the mean in the standard normal distribution. So we are going to take the positive z-score for the 90 percentile. Then now I have to go to the, it was the negative z-table, and now we have to go to the positive z-score. And who was the probability? 0.9. So where is the 0.9? Let me see. .9 between two probabilities, 0.8997 and 0.9015. So between these two, there is a probability 0.9. But what do we need? A z-score. So we have to take two z-scores, positive 1.2, 8, and 9. Positive 1.2, 8, and positive 1.29. Take the average. Average will be positive 1.285. For whom? 90 percentile. With the probability 90.9 to the left. So let me take the z-score, 1.285, and go back to here. 90 percentile. So the 90 percentile will be, take the mean plus the z-score. How much was the z-score? Positive 1.285 times standard deviation, 16. So how much will be the 90 percentile, please? Anybody? It must be bigger than 100 because the 90 percentile was on the right hand side.
120.56.
120, what?
120.56.
120.56. It is the 90 percentile. Absolutely. The first quartile was less than 100, 89.2. And the third quartile is actually, it was a 75 percentile, which was bigger than 100, 110.8. And now the 90 percentile is bigger than third quartile, 120.56. Okay, so we can complete the map. So now we have any kind of normal distribution. We took the z-score. How? Sorry, just a second. Take the z, x minus the mean over the sigma, standard deviation. Then take the probability from the z table. Even reverse way, we can take the z-score from a probability, and even we can take any score from any kind of normal distribution using the formula x is equal to mu plus the z-score times the sigma. Okay, so please remember this map. We can take anything.